Okay, so the rumor that Apple would announce some sort of AR or VR equipment started over a year ago. Then at the WWDC in 2023, those rumors finally became reality. So a few days later, we gained access to the simulator, and like many of you, I opened its code and ran our application to see how they will look like in this new environment. So I would like to start by sharing my experience from that point. My name is Daniel James. I'm an iOS engineer at Zalando in Dublin. And in my spare time, I'm an indie developer. I have 3 applications on the store. One of them is HomeAR, which we'll explore in more detail shortly. Then there is Crew, which is a client for Stack Exchange, Stack Overflow, all these kind of channels. And then Gym Hero, that basically simplify your workout and gym routine. So Apple Vision Pro is such a new platform. We have been developing applications and interfaces for years, but the era of spatial computing brings a whole new set of challenges, but also a lot of familiarities if you approach it the right way. So back in June, when the simulator was released, I thought, OK, what can I do? My very first application was HomeAR. HomeAR with ARKit allows you to place 3D furniture from well-known brands in your space, all through your iPhone. So it basically enables you to see how good design can enhance any space, whether it is your studio, your office, your living room. So I thought, this is the perfect scenario. It's finally time for HomeAR on VisionOS. So I develop it, I refine it, and launch it. A few weeks later, I received an email from Apple saying, congratulations on launching HomeAR as one of the first applications on the VisionOS store. Would you like to come to the lab? So I couldn't believe it. It was a once-in-a-lifetime opportunity. So I booked my hotel, my flight, and headed there. So I spent 2 days at the lab where Apple had prepared the headset with my prescription lenses to develop on. So I had my code, my computer, and I had to tell you, I was blown away by this. I came out of this thinking, this is exactly where I want to go with this. So it was incredibly useful because besides experiencing it firsthand, I was able to familiarize myself with gestures that are at the core of both the VisionOS and HomeAR. So in the simulator, it's hard to perform a pinch, drag, or simultaneous gesture together. And being able to experience these interactions was invaluable, and I had great fun. So returning home, I thought, OK, what's next? There is so much to learn if you want to develop for VisionOS. So there are concepts like windows, volumes, 3D elements that you need to grasp, because if you want to create a more engaging experience, you need to learn this concept. You might want to learn ARKit, RealityKit, concept that people have been working on for years. So I wonder, are there others doing interesting stuff from whom I can learn more? So now, before we dive into this journey, I want you to imagine you are the ones wearing it. So as you watch this video, take a moment to immerse yourself in the experience. OK, we are in. So we were saying, perhaps by looking at what others have created, we can find inspiration and learn more effectively. So actually, while at the lab, I had the opportunity to meet the team behind Immersion Golf, and it was truly inspiring to witness their work firsthand. So they basically created an immersive golf experience that leveraged VisionOS and Reality Composer to help golfers enhance their game, and all from the comfort of their home. So it's like having a personal coach right in your headset. So this is a great example of how VisionOS can enrich our everyday hobbies and activities in ways we never imagined before. So another application, I came across Magic Room, that does an amazing job showcasing the experience of wearing an headset like this, because for many people, this is a completely new concept. But for those of us who are becoming more familiar with AR and these kind of technologies, you put the headset on, and you can interact with the space around you. So it's truly incredible. So Magic Room primarily showcases the debug interface, and creating this basic version is not overly complicated, but what's inspiring is how people have responded to it, because they were blown away by the idea that the headset can gather all this information and map your surrounding. So we might just see it as a technical feature, but for people that have never experienced AR or VR before, it feels magical. So another app that really showcased the potential of VisionOS is Pocket Rocket. It was developed by a team, a rocket enthusiast, who gathered a few 3D models. And like HomeAR, it's inspiring to experience it through your iPhone. But with VisionOS, now the experience is taken to a whole new level. So you can see Rocket at their actual size. You can observe their evolutions. So it feels like standing in the space next to these feats of engineering. So this simple announcement shows how we can elevate our project by integrating spatial computing and make our application far more unforgettable and great experience. So another app that really stood out to me is AR Helicopter. So the developers start with a simple concept, a simple 3D models, and add controls to it. So it allows you to fly around your environment. So it's a lot of fun because it's like having a drone ready to explore any space you are in. So what's inspiring about this project that I want to show you is how it highlights the ease of creating this kind of experience, because the developer didn't start with high budget resources or complex mechanics. Instead, it took a simple concept and transformed it into something enjoyable. So actually, Apple already provides us with a set of 3D models that we can download for free, add into Reality Composer, and integrate to our projects. Most of them contains also animations, and this makes it easier than ever to get started with spatial computing. And also, by using readily available resources, we can focus on creating great experience instead of having to get bogged down by starting everything from scratch. So if you want to learn Reality Kit, this is the perfect example. So this is Blackbox, an evolution of the Apple Design Award-winning app for iOS. So the developer reimagined it for VisionOS, transforming a touch-based experience to an immersive puzzles that surrounds you, where you can interact with bubbles. So what I found fascinating is how the developer took advantage of VisionOS to create this peaceful and curiosity-driven environment where you can interact with bubbles and engage with multiple senses. So this is not just a game on a screen anymore. Instead, it is an immersive experience that surrounds you, where you can interact with multiple senses. So this shows how we can create a more engaging experience that engage with users in entirely new ways. And another great application is Porsche Race Engine. It was developed by Cyril, or Porsche probably. So Porsche has utilized VisionOS to revolutionize the way engineers collaborate and make real-time decisions. So it basically enabled them to visualize complex data, interact with it, and enabling them to optimize performance. And this is a great example of how VisionOS has the potential to revolutionize our professional workflows and the way we collaborate. So the same can be seen with Microsoft 365. Applications like Word, Excel, and PowerPoint are no longer confined to a single screen. Instead, they can appear side by side in your physical space, again, transforming the way we work, revolutionizing the way we work. OK, so by looking at what others have created, we are reminded that innovation doesn't always require starting from scratch. Sometimes it's about taking a simple idea, like Home AR, Pocket Rocket, and transforming it with the tools at our disposals. So VisionOS opens up a world of possibilities, and with inspiration from this example, we can all contribute to build the future of AR. So now, it's one thing to talk about how powerful this technology is, but it's even more inspiring to see how people are actually using it. So recently, a survey was conducted among VisionOS early adopters, where people just like us who had the opportunity to experiment with the device since its release. And what we found is pretty fascinating. So nearly 45% of them are using the Vision Pro every day. And it's not just for entertainment, because for sure watching movies in your immersive space feels like having your own personal cinema. But almost 3/4 of them are also leveraging it are leveraging the device for work and productivity. And they are even replacing a traditional device like MacBooks or iPad, diving into spatial computing in a way that makes multitasking feel more intuitive and powerful. So some of them are even replacing TVs and gaming console, fully embracing the potential of VisionOS for all kinds of experience. And what about the feedback? The feedback is overwhelmingly positive. So the average satisfaction rating is 8.2 out of 10, which is pretty remarkable for a first-generation product. So people are excited about the possibilities. And that's where we, as developers, come in, because we get to push the boundaries of what this device can do and build experience that inspire others. So now, let's shift gears a bit. we have talked about how powerful this technology is. We have seen what others have done. We talked about the potential of VisionOS. But I know many of you are wondering, are thinking, how do I actually bring an idea to life? So I want to dive into the practical side. It's time to take a simple idea, like placing and interacting with an object, and transforming it into an immersive experience using Reality Kit. So I want to cover a few basic concepts like object placement, which is the foundation of every AR experience, lightings and shadows to create more realistic visuals, collision and simultaneous gesture handling to make sure that we can also interact with objects, and finally, spatial audio and animations to create more believable experience. So let me open Xcode, and let's dive into the practical side. So we want to place our toy plane. Let's start by placing our toy plane. This is where our journey into spatial computing begins. So we want to create our toy plane and place it exactly 1 meter away from us. OK, so I defined the make toy plane function, which is basically loading our entity asynchronously to keep our app responsive. And then I'm using the translation property to place our toy plane 1 meter away from us. So you have to imagine this translation property as a 3-dimensional array where we have the x, the y, and the z. And we are using the z to place it exactly 1 meter away from us. Then I'm adding the content. And as you can see, we placed our toy plane. This may seem simple, but this level of controls already allow us to create great experience to start off. So next up, let's make sure our toy planes looks like it belongs to the real world by adding some lightings and shadows. So this is what makes our toy plane feels like it's actually here with us. So to better observe shadows, I want to place our toy plane 10 centimeters above the floor. OK, what this function does is basically loading an environment resource called image-based light, which usually comes for free when you create a new VisionOS project. It's nothing more than that. You can create your own or download it online. Then I'm using grounding shadow component to make sure I can cast shadows on our objects, and I'm applying all this lighting to our toy plane. So let me build again the project. OK, notice how shadows adds a sense of presence to our toy plane. In a real environment, shadows help us perceive depth and positions, and we can replicate all this kind of behavior and even more on VisionOS. OK, now our toy plane is shining bright, but we want to make sure we can interact with it as well. So let's create a collision component and some gesture to make sure we can interact with it with our hands. OK, so I defined this configure collision function, which is basically creating a collision component based on the shape of our plane. And then I'm using the input target component to allow the plane to respond to user input, like touch, drag, and new gestures, and also with other objects and the environment. So let me register. Next, I'm going to define the plane gesture. So this may seem a lot of code, but let's work through it together. So we are holding the state of our transformation, and inside our body, we are defining the drag gesture simultaneously with magnified gestures. Then, whenever this value changes, we are going to respond to it. So since we have multiple gestures here, the first one is going to be a translation, while the second one is going to be a magnification. So whenever we receive a translation, we are going to convert it from local to parent coordinate system, and then we are going to apply our new position to our toy plane. Instead, if we receive a magnification gesture, we are going to scale our toy plane accordingly. So whenever the gesture ends, we are going to reset the status. So sorry, said. Oh, sorry, my bad. Okay, thank you. So this shows how we need this collision, and I actually want to show you something greater, so we can now interact with our toy plane. There is a shortcut. If you hold Shift, you can move it in this axis, and then we can also increase its size. And you point out about this collision, and I want to show something great, because if you enable the debug menu and enable this collision shape and axis, you can notice how our toy plane now has this collision, which is what help VisionOS understand that we are colliding with our gesture inside with the plane. Okay, so our plane is almost ready for takeoff, but let's give it a proper runway. So we want to use VisionOS anchoring capabilities to make sure that we can place our toy plane in real-world surfaces. So I define this anchor entity, which is basically helping VisionOS understand that we want to place our toy plane on a surface that reassemble a table with an horizontal surface with these minimum bounds. And then, instead of adding our toy plane, I'm going to add the table anchoring that is holding the toy plane as well. Oh, I always forget to, I need to remove the translation property, otherwise it's going to replace it 1 meter away from the table. Okay, notice how our toy plane is now placed on real-world surface, and this is what makes our experience way more believable and realistic. And you might wonder, how is it possible? And now, again, by enabling this surface debug mode, I can see all the information that VisionOS has, so it can map floor, wall, tables, and basically everything. So it's pretty cool. Okay, to complete our experience, we want to add some spatial audio and animations. So we want the toy plane sounds engines look like it comes from the plane itself and move as we move it around. Then we want to add some animations. Okay, so I define this configure audio function, which is basically creating a new entity and assigning an MP3 file. Unfortunately, this doesn't come for free when you create a new project. It's a simple MP3 file, and I'm adding it with a few configuration properties like preload and should loop, and then I'm adding all this new entity to our toy plane. Next, we want to add some animations. So as I mentioned, most of these models already comes with animations for free. So we are looking if there is any available animations on this entity. And if there is any, we are going to play it with repeat mode. Okay, as you can see, the plane has this sound and change as we move it away from it. So this makes our experience way more believable and real. So let me stop it now. So in just a few lines of code, we attach the fundamentals of creating immersive experience. So And Apple actually, so let me open again our slides. And Apple provides a wide set of examples from physics simulation to gaming examples to help us dive even deeper. So my hope is that from these examples that you all live inspired from today's sessions to start a small experiment and share your work with the world. So we are the first to explore what AR can do, and each one of us has the chance to shape its future. So start a small experiment, share your work with the world, and I'm really excited to see what you build and how you contribute to build the future of AR.
Thank you so much, Daniel. Good. There will be no questions for this talk. We're a bit early on schedule, so it's a bit longer than otherwise. Check your papers, badges to see what time you need to be back.